Good morning, everyone. Today we present extending open journal system with a hybrid article recommendation model. We developed an intelligent recommendation plugin for OJS that helps readers discover relevant academic articles in an era of information overload. Information overload is one of the biggest challenges in academic publishing today. Researchers are overwhelmed by thousands of new publications every day. We propose a hybrid recommendations plugin for Open Journal System or OJS. OJS is one of the most widely used platforms for editorial management worldwide. Our goal: help researchers and readers find relevant content fast or efficiently. Why did we do this research? Four key reasons. First, academic repositories have too much information. Even dedicated researchers can't keep up. Second, readers struggle to find relevant articles among thousands of publications. Third, OJS has a great personalization features, but its recommendations tools are basic, just recent articles or must download or must read it. Fourth, this missed opportunity, we can significantly improve user engagement with better recommendations. Okay, WADI and OJS. The Autonomous University of Yucatan uses Open Journal System or OJS extensively. WADI publishes scientific articles in multiple journals across all its faculties. This makes WADI an excellent tested bed for our system. The diversity of disciplines help us evaluate how well our recommendations work across different research areas. Our system uses a hybrid approach with two techniques. The first is the content-based filtering. We analyze article metadata. We use titles, abstract keywords, and authors. We use the transformer models to understand the deep meaning, not just keywords. This finds relevant articles even when they use different words to similar concepts. The second is collaborative filtering. We track user behavior, what people read, download, and engage with. By analyzing patterns across users, we find articles that research with similar interests found valuable. We use uh, uh, the system build a table of the user behavior. You can see on the slide this table. Um, the challenge: collaborative filtering has a cold start problem. It needs user data to work well. That's why the hybrid approach is crucial. In the next slide, I can explain more. We combine both approach with a weighted formula. You can see the formula on the slide. PS in the formula is content-based score. PC is collaborative score. and PP popularity score. We use content-based score with a high weight because it's important um, the similarity of articles. This weighting ensures articles are topically relevant while incorporating what users actually find useful. The hybrid approach solves the cold start problem and increases the diversity. Okay, here we have a system architecture. The system architecture have a three-layer design. The persistent layer is OJS native database who stores article metadata like authors, keywords, abstracts, title, and custom tables track user interaction. The processing layer is the heart of the system because we have an external component who is built in Python and fast API engine. Does the heavy work, transformers embeddings, k-means clustering, cosine similarity. And we have the presentation layer, is the last layer. OJS plugin displays recommendation, shows personalized blogs on homepage and article page. The key benefit, heavy processing happens separately from OJS, keeping the platform fast for the users. Let me walk you through how the system works step by step. Step 1, data collection. The OJS database contains all article metadata, and when a user visits the journal, their interactions are logged. That what they read, click, and download. Step 2, API communication. The REST API acts a bridge. It sends article metadata and user interaction data to external recommendation engine. Step 3, processing. The recommendation engine does the heavy lifting, generates embedding using transformer models, groups similar articles and users with k-means clustering, calculates relevance score using our hybrid formula, ranks articles for each user. Step 4, results delivery. The engine sends back pre-computed recommendations through the API. Step 5, display. The OJS plugin retrieves these results and displays them as personalized blogs on the home page and article page. This happens in batch jobs every few hours. So recommendations are always fresh, but never slow down the user experience. Let me show you how this looks from the user's perspective. For regular users, when you visit a journal homepage, you see a personalized recommendations for your blog. These recommendations are based on articles you have read before, your download history, what similar research are reading. When reading an article, at the bottom of each article page, you see related articles, papers that share similar topic, methods, or research questions. This helps you discover connected research naturally. Behind the scenes, the system runs batch jobs every few hours during these jobs. The result, Zero performance impact. Recommendations appear instantly because they are pre-computed. The system handles thousands of articles and hundreds of simultaneous users without any slowdown. This architecture makes it practical for real academic environments with limited resources. We evaluated the system in two critical areas, usability and recommendation quality. For usability testing, we required 10 diverse participants with experience and without experience in academic research. This diversity was intentional because we wanted to test real-world scenarios. Our system achieved a score of 88.25 out of 100. To put in this context, a score above 80 are considered excellent. This means our interface is highly intuitive and user-friendly. For recommendation quality, we tested the system on 150 articles using three standard metrics: precision at K, recall at K, and F1 score. The content-based model alone achieved a perfect score with 100% precision and 100% recall. This proved that our semantic understanding using transformer models works good. The hybrid model initially showed a moderate performance with precision of 53% and recall of 48%. This one, where we had a minimal user profile and data in the system. But here's where it gets really exciting. After incorporating detailed user profiles and behavior data, the performance improved dramatically. Precision jumped to 93%, meaning of your recommendation were actually relevant user. Recall reached to 95% of the relevant articles that existed. The overall F1 score hit 94%. The key insight here is that the system learns improves over time. We successfully integrate a sophisticated hybrid recommendation system into Open Journal system without modifying its core. Our external processing architecture maintains platform stability while enabling advanced IA capabilities. Our hybrid approach effectively combines semantic understanding with behavioral learning, reducing cold start problems and improving recommendation diversity. The system continuously learns and improves as it gathers more user interaction. Most importantly, this work demonstrates that academic publishing platform can adopt a advanced recommendation system scalably and reusable way. The architecture we develop could be adapted for other repository systems, opening doors for more intelligent academic tools. Thank you for your attention. I'm happy to answer questions.